In question number 2, we're once again going to be given a sequence, a list of numbers, and a bunch of questions about that sequence. To make our lives easier, I'm going to suggest that we do something that this question doesn't ask us for specifically, and that's to make a table. I'm of the opinion that many sequences are easier to think about when we have a table to think about instead. So if you have some time and some space, I would recommend that you make a little table next to that sequence so that we can start to immediately think about these things in more concrete terms. The first thing I want to do is just align myself so I know what they're giving me. The first number in the list that they're giving me isn't labeled. I don't know which term in the table it's supposed to be until I use a bit of common sense. But I'm going to say that phrase again. The first term in the list they gave me is 4. So logically, that tells me that the first term in the table, n equals 1, must be that 4. So notice how I'm going to just assume that the first term is the first thing they gave me. First term is 4. That means the term after that must be the second term, which is 9. After that would come the third term, which is 14. After that would come the fourth term, which is 19. So I'm going to extend my table just far enough so I can see what they're giving me here. Now let's look at the numbers. Let's look a little bit deeper. 4, 9, 14, 19. If you're thinking about a pattern here, hopefully you've already spotted it. This pattern is adding by 5. 4 plus 5, 9 plus 5, 14 plus 5. And that means that if I'm adding 5, I must have an arithmetic sequence. So notice in the first part, I circled A for arithmetic. Now that we know it's arithmetic, we need to, in letter B, write an equation. This is where it might be helpful to revisit the notes we took at the beginning of this lesson, the arithmetic equation that we studied on a previous page. I'm going to just quickly copy that note so I don't have to keep awkwardly flipping my paper back and forth. The arithmetic equation needs an initial value plus an adder followed by n. So there's a little times dot there if you want to think of it that way. I need those two pieces of information. I need an initial value and I need an adder. We just talked about the adder a few seconds ago. We know that this sequence is adding by 5. So that's tipping me off right now. I know that the adder is going to be a plus 5 because I'm adding 5. The initial is kind of a different story. The initial value is always the term that we call the 0 term, which they did not give us. That's okay, we can use a little common sense. The initial value is always the term before the first term, the 0 term in the table. So you can think two ways. One way you can think of it as, is, if something was adding by 5, what number was in this space so that plus 5 would have given us 4 as an answer? Another way you can think of it is to just think about the numbers backwards. 19 minus 5 would take us to 14. 14 minus 5 would take us to 9. 9 minus 5 takes us to 4. So 4 minus 5 must take us backwards one more spot. And you can always check the numbers the other way as well. Negative 1 plus 5 is 4. Plus 5 is 9, plus 5 is 14, plus 5 is 19. So it looks like the pattern works both ways. And that means I know my initial value must have been negative 1, because that's the number that would have made the pattern keep going. So my equation, when I piece it together, is going to be T of n equals, the initial value is negative 1, plus, because I'm adding, 5n. The n always gets attached to the adder, but you don't have to do anything with it. It just kind of goes along for the ride. Now that you have an equation, we have a choice to make about question C. In question C, it wants us to find the value of these expressions, and we'll start with T of 0. Now, in the previous video, you saw T of 0 is really just referring to the 0 term in the table. You can think of that value, 0, as the n value, because notice we usually say T of n, now it says T of 0, so the 0 literally took the place of the letter n. And since we have a table to look at, we could say to ourselves, well, just look at the table and look at where n is 0. Whatever number is in that spot of the table is the number that we want to use. That's an awesome strategy if we have the table. that tells us those things. So like the second part, we're going to run out of luck because my table doesn't go all the way down to 7. Now you can extend your table to 7, that would be completely fine, or you can think about another way. Some of us explored this other way on page 4 in the problem about James and Carla. Remember James and Carla with their 2 different ways of looking at a question? This is where having a couple of different options can come in handy, because another way that we can do these problems in letter C is to think about the equation that we wrote. Remember that equation that we just wrote? T of n equals, and I'm going to copy my equation, -1 plus 5n. Well, if n is 0, doesn't it make sense that we could just plug n, 0, into the equation right there? In other words, t of 0, plugging in n as 0, could be -1 plus 5 times n is 0. Notice I just did a little substitution. Think about that math. If you think about that math, you have -1 plus 5 times 0 is 0. -1 plus 0 is -1. Of course, that's the same answer we got from the table. It should have been the same answer. So the moral of the story is, if you want to use the table, because you have a table and it's easy to use it. If you'd rather use the equation, use the equation. But you'll have to think critically, because in part 2 there, you'll have to think for yourself. How far would you have to go to get to the 7th term? And do you have the patience to go that far? If that's fine, then just extend the table to the 7th term and find your answer. If you don't feel fine with extending the table, maybe that just sounds like too tedious for you, then try the equation approach and plug in n as 7 and simply do the math with the equation. You'll really have to reckon with the third part though, because the third part wants t of 20. So then you really have to ask yourself, what's more efficient? Do you want to extend the table all the way down to the 20th term and keep adding 5, adding 5, adding 5, adding 5, adding 5, because it'll work? Or you could take the equation, plug 20 into the equation where the n goes, and see if it works better that way. In any case, those questions are a little bit more food for thought, things that I just want you to try. The last question that I want to make sure I go over here so that you have some examples is question letter D. This one looks a little different. It says t of n equals 29. I'll do that in a separate video. So let's make sure we understand part C first, and then I'll talk about parts D and E. If you feel like you understand it, you want to just do it all at once, that's great. Otherwise, take some time to do letter C first, make sure that idea makes sense. In the next video, we'll look at letter D.